Okay, so now we're doing lesson 2.7 still, module 2, lesson 7. And your learning goal seems very similar to what we did last week, huh?
Yeah.
Yeah, it's to use two ways to do multiplication. We're going to use the area model, and we're going to use the standard algorithm to multiply, but now we're going to do 3 and 4 digit numbers. So the numbers just keep getting bigger and bigger. Does that mean it's harder to multiply?
No.
Yes and no. Is it harder to multiply? No. Are there more numbers to deal with?
Yes.
And when there's more numbers to deal with, what might happen? You might make careless mistakes if you're not being very neat and precise with your work. Okay? I do want to put this on the recording. Why do you think we use two different ways to solve it? Why do you think we use the area model and the standard algorithm? Jaden?
To make sure, like, if one of them's, if there's one answer and then there's another answer, that means one of them is wrong.
Yeah.
But if you get the same answer.
If you get the same answer using two different methods, does that mean your answer's right? Yeah. Let me tell you what I noticed when I was grading the weekly check-ins. A lot of you did your area model, but then unfortunately you made a mistake in multiplying or finding your partial products. Then when you had to do the standard algorithm, you didn't actually do the multiplication. You just copied the partial products from the area model over to the standard algorithm. Give me a thumbs up if you think you did that. Or you didn't actually do the multiplication again, but you just copied the partial products. Unfortunately, for those of you who did that, if you made a mistake in the area model and you didn't actually do the multiplication in the standard algorithm, did you get the right answer? No, and a good number of you did that. Okay? So we want to make sure that we're solving it using two different ways so that if we get the same answer, we know that we're right. Does that make sense? Very good. By now, these directions should look familiar to us. Draw an area model and then solve using the standard algorithm. Use arrows to draw the to match the partial products from the area model to the partial products in the algorithm. Have we seen this before?
Yes.
What's different this time, though? We have 481 times 352. What's different about this from what we did before? Jaden? It's 3 digit by 3 digit. So go ahead and let's first copy this problem into our math notebooks. 481 times 352. And today let's reverse it. We usually do area model first, but today let's do standard algorithm first. Okay? So go ahead and write it 481 times 352. Okay? The first part of the standard algorithm that we're going to do, of course, is 2 times 481. Okay, so what's 2 times 1, everyone? 2. What's 2 times 8?
6.
No, it's not.
16.
16. But we'll put down the 6, and then we're going to regroup those 10s to become, 10 of those to become 100, right? And then what's 2 times 4? 8 plus 1 is?
9.
So what's 2 times 481?
962.
Very good. The next part of the standard algorithm we're going to do is really 50 times 481, right? But then in the number 50, is there any multiples of 10?
Yeah.
How many factors of 10 are there in 50? So just like what you were doing for your sprint, we can ignore those zeros for right now, right? But what would we need to do in the end? Add the 0. So that's why we need to put this 0 here. And that's why an X or a blank space doesn't do anything, because it doesn't change, it doesn't add the multiple of 10. Does that make sense? So make sure to start by writing your 0 there. Now we can do 5 times 1, which is? Okay. We can do 5 times 8, which is 40. So we're going to regroup all 40 of those. Okay. And then 5 times 4, which is? 20 plus 4 is? 24. Okay. So go ahead and record that. Then we're moving on to the last one, which is really 3. Is it 3 times 481?
No.
It's really 300. So how many multiples of 10 do we need to record? 2. So go ahead and write 2 zeros, because anything we do automatically is going to start in the hundreds. Does that make sense? Okay. Now we're going to do 3 times 1, which is? 3. 3 times 8, which is? 24. So we'll record the 4, but we're going to regroup the 2. And then 3 times 4, which is? 12. Plus 2? 14. So which one's our right answer? 962, 24,050, or 144,300?
None.
Those are all
Partial product.
Good. So then in order to find the total product, we have to add up the partial products. Okay? So how many ones do we have altogether?
2.
How many tens do we have altogether?
11.
11. We're going to regroup. How many hundreds do we have altogether?
13.
13. So again, we have to regroup. How many thousands do we have altogether?
9.
Okay. How many 10,000s do we have altogether?
6.
And how many 100,000s do we have altogether? So our final product should be 169,312. Okay, to draw the area model, we always start with what shape? A rectangle. Very good. Okay. What factor is on top of our standard algorithm? 481. So what number needs to be on the top of our area model? 481. How can I break up 481 to make it easy to make an area model? Jaden?
400.
400
Plus 80.
plus 80
Plus 1.
plus 1. Very good. What factor should be on the side? 350, 2. So again, we're going to divide it, but we're going to have 350 and 2. Now what we've been doing is we've been writing, what would we write in this box right here? 300 times 400, right?
Yeah.
But if you are at the point where you feel like I've had a lot of practice and I'm not going to make any mistakes, you can just write the partial product in here. So I can write 300 times 400, which is 12, plus how many zeros? So I can just write this in here. But let me tell you something. Can I give you a word of advice? A lot of people are making mistakes with the numbers of zeros they need to write. How come I write 4 zeros here? Because there's 2 here and 2 here. If you're the kind of person who really wants to make sure you don't make any mistakes, you would still write 300 times 400 equals, because then you can see those zeros right away. Okay? But if you're someone who thinks, oh, I never make careless mistakes, then you can just write this here. You know yourself best. Well, actually, I probably know you pretty well too, so I know which ones of you should write it out and which ones shouldn't write it out. Okay? Does that make sense?
Yeah.
How would we find the area of this square here? I have to do 300 times 80. So I can do 3 times 8, which is 24. And then how many zeros do I need to add? 1, 2, 3. So 1, 2, 3. So that partial product is 24,000. Okay? What about this one? What 2 factors do I have to multiply to find the area of this area, or this section right here? Ananya? 300 times 1, which is 300. So we'll go ahead and write 300 right there. Okay? How do I find the area of this? What 2 factors do I have to multiply to find the area of this section right here? Help me. 400 times 50. So I can do 4 times 5, which is 20. And then add how many zeros? 1, 2, 3, because there's 2 up here and 1 here. Very good. What about this middle box? What 2 factors do I multiply to get that area? Jithia? I multiply 80 times 50, so I could do 8 times 5, which is, everyone? 40. And then how many more zeros do I have to add? 2. So the answer is 4,000. This last one over here, I have to multiply 50 times 1, which is 50. Okay. And then the bottom left right here, I have to multiply 400 times 2, right? So that's 4 times 2, which is 8. And then how many zeros do I add? Okay. Over here, I have to do 80 times 2, so that's 160. And over here, 1 times 2, which is 2. Yes? Okay, very good. I'm really doing 300 times what? 481, right? So I can do 120,000 plus 24,000 plus 300. Yes? To find out the total area of this horizontal piece. Do you guys agree? Yeah? So it's 144,300. Have we seen that partial product before? Yeah. It's the same partial product as when we did 300 times 481. Do you see that? Yeah. On your weekly check-in, a lot of you forgot to draw arrows to match them. So you also lost points for that. You'll notice it's part of the directions. Okay, now this next middle slice, what's the factor on the side here? 50. And if I find the total of this, is it all of this at the top? Do you guys see that? So let's add that up. 20,000 plus 4,000 plus 50. What does that equal? 24,000 and 50. Have we seen that partial product before? Yeah. Okay. And then the last slice, it's 2 times 481. Do you guys see that?
Yeah.
So it'd be 800 plus 160 plus 2, right? So it's 2, 6, 9. So 962. Have we seen that partial product before?
Yeah.
Okay, so do you guys see how when we find the entire slice like this, it's doing 2 times 481, which is what we did over here, 2 times 481, right? So do you see how we actually, did I just take the partial products and copy them over